In these problems, we're being asked to solve a system of two equations by what's called the elimination method. If you've used the substitution method before, you know you can solve equations like this by solving one of them for a single variable and then using that to substitute in for the variable in another equation. If you're used to doing that, you may find the elimination method really fun and easy. All you have to do is add the two equations together in such a way that one of the variables disappears. So sometimes you have to manipulate one of the equations, but in this one, look at this one, we have a 3y and a negative 3y. If I were to just put a sum line under here and add down the columns, the y's would disappear. So that's exactly what we're going to do. So 4x plus 3x is 7x. A positive 3y plus a negative 3y is 0 y's, so I'm not even going to write it. And 24 plus a negative 3 is 21. Look how easy that was to get this single equation with one variable. To solve this for x is trivial. We just divide by 7, we get x equals 3. Once we're at that point, we take this 3 and plug it back into any one of these equations. Let me put it in the top one. 4 times 3 plus 3y equals 24. So this is 12, oops, that should have been a plus. 12 plus 3y equals 24. Subtract 12. We get 3y equals 12. Divide by 3. We get y equals 4. So 3 and 4, as an ordered pair, that would be 3, 4. So pretty cool and easy method. Easier than substitution most times, I think. However, you don't always have conveniently set up equations where a variable is going to disappear just by adding them together. But that's okay, because we can take one of these equations and multiply by something. As long as we multiply both sides by the same thing, it's the same equation. So in this one, I'm going to go for getting rid of this 2y. What I would need down here is a negative 2y. Since I have a positive 1y, I would need to multiply this equation by negative 2. When I do that, I multiply every single term by negative 2. So let's do that. Negative 2 times negative 2x is negative 4x. Negative 2 times y is negative 2y. That's perfect. And negative 2 times 2 is a negative 4. Don't forget that last number on the end. That's really important. So let me rewrite the first equation above that. 6x plus 2y and 5. Let's go ahead and add those together. Now we have 6x and a negative 4x. That's a positive 2x. Our 2y and negative 2y come out to 0. And here, 5 minus 4 is 1. So I've got 2x equals 1. We're going to divide both sides by 2. And we get x equals 1/2. Pretty easy. Let's take that 1/2 and plug it in. Well, let's plug it in this one. It looks a little simpler. So we'd have 2 times 1/2 plus y equals 2. 2 times 1/2 is just 1. And plus y equals 2. We subtract 1 from both sides. We would get y equals 1. So our ordered pair for this one would be 1/2, 1. And that is how to use the elimination method to solve a system of two equations.